So we are going to continue our discussion of expressions in section 8.1 and talk about doing some translating. Right? When we're doing translating, right, the idea is here, in some ways we can definitely think about math as a foreign language. Right? So we can translate English sentences into algebraic or math sentences. Right? And as we're doing this, we're going to translate our English sentences into algebraic expressions. As we proceed through the rest of the semester, we're going to keep coming back to this idea. Anytime we're thinking about story problems, that's also in essence what we're doing. Right? We're changing an English sentence or story problem to some sort of mathematical expression. So what I've done here is I went ahead and filled in this chart of our different keywords, just because I want to kind of talk a little bit about those without actually writing every single word down as we go. Feel free to print this off and or fill it in yourself as you're going through. So what we have here, we have our four basic operations: addition, subtraction, multiplication, and division. And then we also have a row in here about exponents. So we're going to talk a little bit about those as well. All right, so starting with addition. Our answer to an addition problem is a sum. So that's definitely a word that we want to think about when we're using addition. Words like plus, increased by, total, right? All of those words should indicate addition to us as well. Our answer to a subtraction problem is called a difference. So we definitely want to include that. Right? Instead of plus, well, we have minus for subtraction. Instead of increased by, we have decreased by, right, for subtraction. We could even actually see the word subtracted from in there. And then I put these ER words in there with a how much above there, meaning that sometimes with our ER words we might see how much taller, how much shorter, how much longer, right? How much more, which I guess isn't necessarily an ER word, but all of those kind of words do indicate subtraction as well. Right? Multiplication. Again, our answer to a multiplication problem is a product. We see words like times. Double, triple tell us exactly what we're multiplying by. Double and triple are not exponents. That's a multiplication that's going to go out front. And then I also put the word of in here because sometimes we use of as a multiplication if we're dealing with fractions. What is half of something? Or if we're dealing with a percent or something along those lines. All right, for division, our answer to a division problem is called a quotient. So we definitely want to make sure we have that in there. We talked about ratios in the last chapter and how we're thinking about those as a comparison using division. So we definitely want to put ratio in there. And then our E words, words like evenly, equally, things like that all mean division as well. Right. As far as exponents go, again, we're not using double or triple, right? Those were in our multiplication row. When we're thinking about exponents, we're thinking about words like squared and cubed. Squared tells us specifically that we have an exponent of 2. Cubed tells us specifically that we have an exponent of 3. Right? And the reason that these words are picked is a square is a two-dimensional figure that has two of the same side, and two equal length side. And a cube is a three-dimensional figure that has 3 sides, right? Length, width, and height that are all exactly the same. So if we see squared, that always means an exponent of 2. Cubed always means an exponent of 3. A square root, we're going to use our square root symbol. We can also use our multiplication table to help us find out square roots. In this case, we're just going to be writing expressions. We don't necessarily need to do that, but that is something handy to know. And then we also might see words like power. Right? Something to the 5th power would mean an exponent of 5. Right? So up here we have a nice handy dandy list of our different operations. And then as we're doing these and thinking about these, you definitely want to be paying attention to these keywords and keeping this list handy as we go through the rest of this semester. All right, so down at the bottom, we have some translating expression problems to work through. So we're going to translate each English expression into an algebraic expression. All right, so the first one that we see, the sum of a number. All right, so if we look back up on our list, right, sum shows up in our addition keywords. So we are going to write the sum of a number and 18. Pick any variable you choose. I'm just going to pick n, and I'm going to write n plus 18. Or if we wanted to, we could put the 18 first, right? We could write 18 plus n, right? Order doesn't matter when we're dealing with addition. All right, for B, the product, well, product, if we see up here, it means times. Right? So we're going to do 6 times n. Or, like we did on the last one, we can switch, right? N times 6. You could also leave that dot out. You could use parentheses, right? The only thing we don't want to use for product is we don't want to use an x for our multiplication, because then we're going to confuse it, or we could possibly confuse it with another variable. Both addition and multiplication, right? Order does not matter. Both of these operations are commutative. Right? Our commutative property tells us that order does not matter. Right? 3 plus 4 and 4 plus 3, well, they both give us 7. 3 times 4 and 4 times 3, well, they both give us 12. Right? So order does not matter for addition and multiplication. Okay. If we look at these next two, right, the difference of 17 in a number and the quotient of a number in 5, difference means subtraction, and so when we write these out, unlike addition and multiplication, order does matter for subtraction. Right? So the difference of 17 in a number means our 17 is going to come first, and then we're going to subtract our number. Certain phrases, such as subtracted from, might actually change our English order, and we actually have to change the order of our variables in order to get the correct answer in these. So as you're going through and doing these problems, pay very careful attention to your order for your subtraction. Watch out for words like subtracted from. Make sure those don't trip you up at all. Right? The quotient of a number in 4. Quotient means to divide. So I'm going to write this as, right, the number comes first. So n divided by 5. Right? Or if we want to use our ratio or fraction notation, right, we could write n over 5. Both of these operations, right, subtraction and division, it matters. It matters which one comes first. Are we getting a positive number or negative number for our answer in some cases? Right? When we're setting up a long division problem, it matters which number is outside and which number is inside. Right? So with subtraction and with division, right, we are not commutative. Right? Order does matter. So again, as you're going through and working through these problems, make sure you're paying attention to that fact. All right, then these last couple, we're going to deal with exponents. Right, so cube, remember, means an exponent of 3. Right, so the cube of a number is going to be n cubed, so we have an exponent of 3. And the square root of a number, we can write the square root of n. As you're going through and you're putting these in my math lab and working through your answers, pay careful attention to kind of as you're working through the problem, and I will make kind of a little note in there, actually in the first problem that requires exponents for you, to make sure that you are getting the exponents in the correct place.